Hello dear students, in this session we are going to solve a numerical on shear stress at different sections. In this question we are given with a circular beam of 100 mm diameter and is subjected to a shear force of 5 kN. We have to calculate the average shear stress, maximum shear stress and shear stress at a distance of 40 mm from the neutral axis. So this is a question of shear stresses where we are given with a circular beam of 100 mm diameter. It is subjected to a shear force of 5 kN. We have to calculate the average shear stress, maximum shear stress, and also we have to calculate the shear stress at a distance of 40 mm from the neutral axis. So let us solve this problem. In this question, we are given with a circular beam, circular cross-section beam, at which a 5 kN load is applied, right? The maximum shear force given is 5 kN, right? We have to find out the average shear stress developed in this beam. The maximum shear stress, we know that maximum shear stress develop at the neutral axis, right, at the center, and the shear stress at a distance 40 mm from the neutral axis. This is our neutral axis, and 40 mm from the neutral axis, what will be the shear stress? And the shear stress at general point is given by this equation, right? So we have to find out these things. So let us solve this question. Tau average. Average shear stress is given by the force upon area. Force is known to us, that is 5 kN, which is multiplied by 1000 upon area. Area is the circular area of this bar, that is pi r square or pi by 4 d square. So pi by 4 d square is 100, diameter is 100 square. So value will come in Newton per millimeter square. So tau average, solving this we will get the tau average, the average shear stress in the beam. So average shear stress will be 0.637 Newton per millimeter square or megapascal. You can see here the value is very low. That's why sometimes we neglect the shear stresses, right? So this is the average shear stress. Now, what will be the maximum shear stress? We know that maximum shear stress for circular section is given by 4 by 3 times the average shear stress. So put the value here and you will get the maximum shear stress. So from here we can find out the maximum shear stress, and maximum shear stress 0.85 Newton per millimeter square. So this is the maximum shear stress, right? So this is one more answer of this question. Third is, we have to find out at general point 40 mm from the neutral axis, right? So tau at 40 mm will be equal to force upon 3 times moment of inertia. Now, what is the moment of inertia of a circular section? That is pi by 64 d to the power 4, right? So this is pi by 64 d, diameter to the power 4, that is 100 to the power 4, right? And what is force? Force is given to us, that is 5 kilonewton. So will become Newton, right? So r square, what is r? Is the radius, maximum outer fiber radius, that is 50 mm. So this is 50 square minus y is 40 mm, right? So this is 40 square. So this point should be, because this is 50, so this should be close to the this point, right? At this, near this may be the y value, right? 40 mm. It is not close to neutral axis, it is close to the outer fiber because outer fiber is 50, right? From here we can find out tau at 40 mm, and that will come out to be 0.31 Newton per millimeter square. So these are the values of shear stresses: average shear stress, maximum shear stress and shear stress at some general point of a circular section.